Hey everyone, it's Mikki here. You're listening to Wikipedia, and this week on the podcast, I speak to Professor Thomas Seyfried about the metabolic origin of cancer. In this conversation, Professor Seyfried outlines why metabolic dysfunction is the major driver of cancer, how we starve cancer cells, how his push-pulse therapy, which he has been working on with a number of top researchers in the field, such as Dom D'Agostino, can go alongside conventional treatment for cancer, where conventional treatment gets it wrong, and lifestyle and nutrition strategies for cancer prevention. I learned a lot in this conversation with Tom Seyfried, and you can hear his passion for getting out this message. And I think that anyone who has been touched by cancer, which is pretty much everyone at this point, will get a lot from this episode. So for those of you unfamiliar, Dr. Thomas Seyfried is an American professor of biology, genetics, and biochemistry at Boston College. He received his Ph.D. from the University of Illinois Urbana-Champaign in 1976 and did his postdoctoral fellowship at the Yale University School of Medicine. Dr. Seyfried has over 150 peer-reviewed publications, and his research focuses primarily on the mechanisms driving cancer, epilepsy, and neurodegenerative diseases in calorie-restricted ketogenic diets in their prevention and treatment. He is also the author of Cancer as a Metabolic Disease. You can find out more from Tom's website, which I have popped in the show notes. Plus, he is really active on Instagram, actually, and YouTube. So you can find out a ton of information where he freely shares a lot of what we discussed today, but of course goes into so much more detail. Before we crack on into the show, though, I would like to remind you that the best way to support this podcast is to hit the subscribe button on your favorite podcast listening platform and share it with your friends, because that way more people get the opportunity to hear from the experts I have on the show, like Professor Seyfried, and amongst literally thousands of other podcasts that are out there. For now, though, please enjoy this conversation I have with Professor Thomas Seyfried. Professor Seyfried, thank you so much for taking the time to speak with me this morning, your afternoon, obviously. Can we kick off with you giving me a little bit of your, backstory about your professional journey and what initially actually sparked your interest in cancer research?
Well, thank you, Mikki. It's nice to be here. I'm assuming I'm pronouncing your name correctly.
You are, yes.
Oh, okay. Well, that's good.
Nice one.
Yeah. And you're located in New Zealand?
Yeah, Auckland, New Zealand.
Wow.
Very future focused here. It's Friday already. This is the future. You're looking at the future.
Yes, I am. And you're looking at the past.
Actually, yes.
Well, we have a terrible battery of lightning storms with hail and everything coming through here in Boston today. But we're so lucky to have only hail and rain and lightning, because the same storm just tore up the whole Midwest with massive tornadoes out there. So,
oh my God! I saw that on the news actually. That's quite remarkable.
Yeah, so we're getting the very tail end of this whole thing. We don't get tornadoes here, but the folks living in the Midwest are always being harassed by these horrific cyclones and tornadoes and this kind of thing.
Yeah, actually, have you been to New Zealand, Professor Seyfried?
I was supposed to go a couple of years ago, just before COVID. I was invited by the Maori tribe, the head of the Maori tribe.
Oh, amazing.
Yeah, I can't remember his name right off the bat now, but he was very nice. We were all planning to go. Then COVID hit and we had to shut it down. But apparently the Maori tribe is riddled with cancer. And he was asking me what kind of approach could we take to manage cancer in this original tribes of the real New Zealand people, right?
Yeah.
So anyway, and he gave me a history he before to let me know who these folks were, and their greatest claim was, I guess, the English could not beat them. They have an interesting history battling foreigners who try to come in and take over their land and things like this.
Actually true. And are you familiar? I'm sure you're familiar with Weston A. Price.
Yes.
And
Yes. Yeah.
yes. And I used to teach at a university, and in one of the courses, there's some great footage on YouTube. It's quite remarkable, actually, of Weston Price's sort of journey through the Pacific, and he described the Maori as being, the most fiercest sort of warriors, and they had such an amazing physique in their natural setting. And in one generation, and even within the same generation, their health absolutely deteriorated because of the introduction of flour and sugar and alcohol and things like that.
Oh yeah, well that's why you guys have these rugby teams. You tap into those kinds of guys and you win all the games.
Actually, yes, but it's really interesting actually what you say about the prevalence of cancer in Māori, because I find it super interesting that particularly in the last. Cancer just seems to skyrocket. It has absolutely seemed to have skyrocketed, and it's what it appears. And I don't know. I'm really interested actually to understand what your thoughts around this are like, Professor Seyfried. But it feels like I try to live a healthy life. Yes, it may decrease my risk, but actually, it seems so random sometimes with cancer. It seems like anyone can sort of be. What are your thoughts with that?
It's a multifactorial problem right now, and it's a combination of the diet and lifestyle together with the increasing types of pollutants like the microplastics, this kind of stuff. It's multifactorial. It's predominantly not genetic. You may inherit risk genes that increase risk, but they by themselves are not sufficient to lead to dysregulated cell growth. And you like people say, we have to define first what the nature of the problem is, and it's dysregulated cell growth is the definition of cancer. So the question is, how does that happen, and why is it on this tremendous increase throughout the world? And we have to put the pieces of the puzzle together. There's two things you need to know. One is the prevention aspect. How does it happen in the first place? What is the cause? What could provoke a group of cells in a particular organ in a particular person to start growing in a dysregulated way, leading to what we then would define as a tumor? So that's one thing. How does it start? And as I said, it's a diet and lifestyle initiation. And we, in a couple of my big papers and in my book, I clearly broke down the origin of cancer and how it all starts. This actually had been wrestled with by Albert St. Georgi, who was a Nobel Prize winner for his work on vitamin C, but he was also big into the cancer field. And he called it the oncogenic paradox. How is it possible that this guy could get cancer from smoking, this guy could get cancer from drinking, or this guy get cancer from eating something, this guy from a chemical, this guy from... How does it all link together in a common pathophysiological mechanism? And the answer, he said, we just don't know. But I solved this problem, and we showed that every one of the what we call provocative agents that has been linked in one way or another to cancer all damage the ability of our cells to generate energy through oxygen. So the organelle inside our cells is called the mitochondrion. It's a very important organelle, probably the most important organelle, and that keeps the metabolic homeostasis of our cells. It maintains metabolic homeostasis. Well, when that organelle becomes corrupted chronically, the cell gradually drifts into attempting to replace the energy through ancient fermentation pathways that were in all cells before oxygen came into the atmosphere in the early history of the Earth. Those ancient pathways are still present in all of our cells, except they play an extremely minor role. But as the cell gradually loses its ability to use oxygen to produce energy, it gradually falls back, and these ancient pathways get more and more upregulated. And then what happens is the organelle that's producing the energy through oxygen and then gradually loses that capability. That organelle is what controls the destiny and life of the cell. But because the cell has now shifted to an ancient fermentation pathway, it loses grip. It no longer can control the destiny of the cell. And the cell essentially falls back the way life was before oxygen came onto the planet 2 billion years ago. And they ferment. And so the organelle that's supposed to regulate this, it's the kill switch of the cell. And when something happens acutely, it usually turns on and kills the cell, so it never could become a cancer. But it's the chronic damage. So what is this chronic damage? Well, it could be carcinogens. It could be radiation. It could be systemic inflammation linked to the obesity epidemic. It could be intermittent hypoxia. It could be a genetic risk factor. It could be a virus like papilloma viruses, oncogenic viruses, hepatitis C viruses, and it's age. All of these things, and then you put that together with an inappropriate diet and lifestyle, where people are under stress. They're not eating correctly. They're not exercising correctly. You're doing all that, and you put that together with the environmental components, and in some of these people, you're going to get cancer. And in fact, a lot of these people, you're going to get cancer. And as the world becomes more globally interactive, highly processed foods can sit on a shelf for weeks and weeks rather than go bad, are engineered to do this. But there's a price we pay for convenience. And that's the loss of what we used to do as a species before global technologies took over. And what's happening is technologies are outpacing our body's evolutionary past. So technologies, the evolution of technology is much faster than the evolution of our biology. We existed as a species for hundreds of thousands of years as hunter-gatherers, and then as farmers, and this kind. We had no highly processed foods. We were working very hard. We had to expend a lot of energy. And now all of a sudden we have a worldwide obesity epidemic. We have a worldwide cancer epidemic of cancer and other chronic diseases. You have type 2 diabetes. You have dementia. You have all of these kinds of things that are all the consequences of change, a rapid change within the last, say, 50 or 100 years to a completely different kind of an environment, a more toxic environment. And we're not doing the same things we did as hunter-gatherers. We're under more stress. We're not exercising enough. We're putting ourselves at risk for all of these provocative agents in the environment. Consequently, we have cancer.
Yeah. Do you often look around at, I don't know, the population? You probably don't often have these big abstract sort of moments of, were we really supposed to live like this as humans? You know, I often sort of like if I'm in like a supermarket, if I'm just out on the street and I just see see exactly what you've just described, like the way that people live their lives. And I'm just think, gosh, was it even ever really supposed to be like this? I don't know, these sort of big abstract thoughts.
I think that's the consequences of our ability to adapt and change the environment. We're the only species, maybe there's others, but that can actually modify the environment rather than just accept the environment you're living in. You adapt to the environment. We began to change the environment. And that's because we have command over things that other animal species don't have. They're hardwired to do things by instinct, instinctively hardwired. When we emerged, believe me, most people still are hardwired in many things they do, whether they know it or not. There's a subcortex in our brain that controls a large amount of our behavior without us really. I think Sigmund Freud was trying to tap into that kind of a thing. I don't go in that direction, but I know that our technology has provided us with things that we have always sought after: sweet foods, not having to work as hard, all of these things. But we pay a price for that. The price is we have all these chronic diseases.
Yeah.
But that doesn't mean we're destined to have cancer, heart disease, dementia. I think the knowledge that we collect also arms us with ways that we can adjust our own diets and lifestyles, knowing that not doing this could give us put us at risk for a variety of different health problems. So, one of the things that we do is, again, it's the prevention. People, when you flip back and forth between treatment and prevention for cancer or treatment and prevention for any chronic disease, you always have to try to separate the two. And in my experience, more people come to me asking me, how can I manage my disease, rather than asking me, what should I have done in my life so I wouldn't have got this in the first place?
Yeah.
That's
like a $1 million question, right?
Yeah, well, no, we know how not to get cancer. I mean, you just got to live like you did in the cave days, but not completely. Because I'm not here to say, let's not eat pizzas and hamburgers and hot dogs. I'm just saying that we need to know how our body responds to this. And I think we need to know to maintain health. One of my Japanese colleagues said there's the cancer. I have it written here on the board behind me, I think. The cancer lifestyle, having no friends, not smiling, not sleeping well, eating highly processed foods, not exercising. So you put all these things together and you are living in a cancer lifestyle and situation. So get friends, exercise more, get better night's sleep, do all the things the opposite of what you would do to get, because everything that when people get cancer, they say, oh, I didn't know I was doing this. And, half of them have every kind of a chronic disease you can think of. Not all. And there's some people, I'm very healthy, Well, maybe they overdid it. Maybe the microplastics in their environment. This is another worldwide contamination in the population. And people are saying, oh, those microplastics are changing hormonal balances in our body.
Yeah.
But the other thing, too, is microplastics are particles, foreign bodies. And there's a big literature on foreign body carcinogenesis. Like if a wood chip or a piece of metal were to be stuck in your brain, oftentimes you see a tumor developing around that or some other part of your body. But if you have microplastic fragments in some part of your body, and then your body launches an immune attack on that, that's a recipe for damaging mitochondria and shifting energy metabolism from oxygen to fermentation and dysregulated cell growth. And then the body looks at it as a wound, throwing in more abnormal blood vessels. And the next thing you know, your immune system is fusing with these cells and you got metastatic cancer. Everything to me is absolutely clear. I mean, we know how to get it, and we know how to manage it. The problem is, it appears like the major cancer institutions are unable to understand that or do not want to understand what I'm telling you.
And I think this is the thing with a lot of the work that you research and that you publish on, is that it almost seems left field of the authority voice. When I say authority institutions that talk about cancer, exactly what you've just described. And then people like me and others who are like, well, this is super interesting. And then you get pushback like, no, that's not the conventional way we think about it. This is, it's not unconventional, isn't the right word, but it's just not a well-recognized theory, I suppose. And so it's very easy for the lay population to sort of go, well, it's not much that we can do, obviously, because it's all got this genetic basis, or we don't know. So why is that? Why is there this tension?
Well, I think it's that's the crux, I think, of the major obstacle. I guess we can define it as the obstacle for moving forward in managing cancer and preventing cancer is the misunderstanding of cancer as being a genetic disease. And our National Cancer Institute, part of the National Institutes of Health here in the United States, which is probably the wealthiest federally supported organization on the planet, They clearly say cancer is a genetic disease. It's made up of 100 different diseases. It's right on their website. Nothing could be further from the truth, because when you look at the data, there's no support for what they're saying. So then how would it be possible for a major federal agency that's job is to protect the population be so misled or unaccepting the new evidence? And like you said, well, it hasn't been proven. Well, it is if you're not cognitively impaired and you can read the scientific literature, you should recognize that this is. But the concept is confirmation bias, ideological dogma, and confirmation bias. So you have an enormously integrated interactions of great institutions, the federal government, the academic industry, the hospital industry, the pharmaceutical industry, all walking in lockstep to the confirmation bias that cancer is a genetic disease. And the people who are suffering immensely throughout the world throw up their hands and say, how could all these institutions be wrong in their assessment of what the nature of this problem is? And the answer is because their power, the power of the institutions, all integrated with each other, create an powerful juggernaut of approaches, all linked to this one idea that cancer is a genetic disease. So all the drugs, all the research, not all, but majority of drugs, majority of research, the private foundations raising money, the federal government spending billions and billions of dollars, not only from the United States, all major Western governments are spending a large amount of money trying to figure out this cancer problem, when the problem is clear if you read the scientific literature and are capable of understanding it. The problem is it's not very much different. Well, let me say one more thing. The reason we persist with radiation, chemo, and surgical mutilations, not to say that we shouldn't be using those procedures. They can be used, but you have to know how to use them in the right context, not the way we're currently using them. And the reason that these standard of care therapies are persistent in all major countries, Western countries, is because the promise of the genome projects, the $100 billion genome project, sequence every mutation, has not come to fruition, and it never will. It's because it's not a genetic disease. And it's hard for people to say, you mean we spent hundreds of millions of dollars on a dead-end project when it wasn't that in the first place? And the answer is yes, I'm sorry to say, that's what was happening. We cannot accept your statement. We have to pursue and continue to do this. And the reason why we continue to irradiate and poison people is because this so-called sophisticated precision medicine and personalized therapy has been a bust for the majority of people. And we're getting more and more cancer every year in more and more countries, younger and younger ages. And everybody's saying, hell, hold on, the cure is coming. Don't you know the cure is coming? Well, based on what? The somatic mutation theory or the mitochondrial metabolic theory? Once the institutions realize that it's a mitochondrial metabolic disorder, then you're going to see dramatic drops in death rates, and you're going to see a very much more improved quality of life and overall survival. So right now, the systems all over the world, whether you're in New Zealand, Australia, Germany, Japan, the United States, England, you go right through all the list of all the countries. They're all doing the same stuff, and it's not working. And it's not working because the theory under which you're looking at the disease is fundamentally incorrect. It's a very similar situation to what Galileo, Copernicus, and Kepler had to go through trying to convince the Catholic Church that the sun was the center of the solar system and not the earth. And they burned Giordano Bruno in a plaza of Rome because he insisted that the sun might be the center of the solar system. The House arrested Galileo. But you see, because the power at the time was the Catholic Church, and they were infallible in their statements, so you could not challenge the power. And we have a very similar situation today when all the institutions think cancer is a genetic disease and it's not, and they're basing it on confirmation bias. That's what everybody thinks, therefore it must be true. It's an ideological dogma. You train the physicians and the scientists to think that the only way you can manage cancer is to target gene mutations. And the gene mutations that we've shown are all downstream epiphenomena of the damaged respiratory capacity of the cell. So you're chasing tails, you're not chasing origins. So you're chasing effects. And that's the reason why, in a nutshell, why we're not making any major advances in managing cancer.
Because there are some, I often see in the paper, there are some medications which, or treatments which are particularly effective for some people. And I'm really ignorant, to be honest, Professor, on what the names of these medications is, but you see that this person got X funding to go into this trial, and this one medication helped put them into remission. So is that's treatment that is different, as I understand, from the radiation and the chemo that has been around for decades. Is that?
Yeah, no, the immunotherapies, they're called CAR-T. They're very sexy. They look like, whoa, this is really, we're going to train your immune system to go in and kill the tumor cell. And yes, every now and then the blind squirrel finds a nut. And you get one of these tremendous responses. I'm not saying. As a matter of fact, when you look at the results from the immunotherapies, you get about 20% of people that really, really do well. They have a high quality of life and they go on. And then you have about 60% of the people where it doesn't really do anything. It has no effect. And then you have 20% of the people that get hyper-progressive disease. This is where these antibodies and these trained immune cells start ripping up your liver and kidneys, and you actually end up dying faster from the treatment than you would have if you did nothing. So and the pharmaceutical, well, at least in our country, I don't know. It's not that they hide this. When you see an advertisement for an immunotherapy, it's always a bright picture of always green and smiling people, but they spend most of the ad telling you how many ways this drug is going to kill you. It's not they're hiding anything. They're telling you right up front that this drug can kill you. Well, why the hell does anybody want to take a drug that has a remote possibility of killing them? It doesn't make any sense. And yet they run like sheep and get into these trials. And I have to laugh at Joe Tippins, who took the fenbendazole parasite medication. In the 300 people in his trial, he was the only guy that took a parasite medication and the only guy that survived. And he didn't know how it works. We know exactly how it works. We published a paper on it. It targets the very fermentation metabolism that the cancer cell needs to survive. So a cheap drug like a parasite medication, it turns out parasites in cancer use the same metabolic pathways to stay alive. So you take these cheap-ass medicines and you get much better effect than the $300,000 CAR-T drug.
Yeah, that's crazy.
I mean, it's unbelievable.
Yeah, and chemo and radiation, that hasn't moved on much since its initial.
Well, I don't know. I mean, they call it gamma knife surgery. The machines look nicer. I mean, they look almost space age. I mean, you walk into a radiation room and you say, whoa, this has got to work because it looks so impressive. What the hell are you irradiating somebody for in the first place? Now, I'm not saying you shouldn't ever irradiate. Well, the brain, I will say you should never irradiate anybody's brain. That's medieval kind of stuff, made to look modern, but it's actually medieval. Yeah, once you get into nutritional ketosis, many of these therapies work so much better. Actually, you don't need as much of it, and you don't. The dosages can be reduced. So we have I've been telling people we have all the tools to manage cancer effectively already today. We just have to know how to better use the tools. And the first way to better use the tools is know that cancer is a mitochondrial metabolic disorder that is dependent almost exclusively on the fermentation of the sugar glucose and the amino acid glutamine. And they can't use fatty acids or ketone bodies. So that's the solution right there. I just gave it to you. You simultaneously target the two fermentable fuels driving the dysregulated growth while keep transitioning the whole body to nutritional ketosis, which protects all of the normal cells that are in tumor. And the tumor cells now become marginalized and can be killed by a whole range of tools that will have much less toxicity and be far more therapeutically effective.
Professor, is this all cancer types? Because when I look at, research or papers, it appears that I'm sure I've seen papers that say that there are tumors which can switch their fuel sources over to using ketones as a fuel source. Is that incorrect or?
Yeah, there are papers that say that, written by people who have of cognitive impairment,
Okay.
who don't read the scientific literature, don't understand the scientific literature. So they collect a few. So here's the situation. They take cells and they have them growing in the fermentation fuels, glucose and glutamine. And then they throw in a ketone body or a fatty acid. And they say, look, you get a 2% increase in growth when you put the fatty acid in there. Isn't that amazing how tumor cells can use fatty acids? I says, try it without the glucose and glutamine in there. And invariably, the cells die. They can't use ketone. We just published a beautiful paper, a blockbuster, one of the great papers I've published. And it's a very simple paper. What we did is we went and we did, I spent a lot of time looking at what tumor cells growing in people look like under microscopy, electron microscopy mostly. Yeah. Okay, what do they look like? And what we found in every one of these tumors that I looked at, which represent 98% of the major cancers, let's put it that way, of the major cancers, brain, bladder, breast, colon, lung, go through all the ones that kill most people, the blood cancers. And they had these, what we call lipid droplets in the cytoplasm. You're going to love this. So they all have these lipid droplets in the cytoplasm. This is a well-known feature of all major cancers. They have lipid droplets in the cytoplasm. So I said, wow, isn't that interesting? So then you read all these papers in the top scientific journals, and it said, see, cancer cells need lipid droplets because they need so much energy, they have to store the fat to use it for energy. And what we found is those lipid droplets are there because they can't use them. It's there to protect the cell. And how do we know that directly? Because other people have done beautiful experiments where you interfere with oxygen respiration, either by going into hypoxia, shutting down oxygen. All of a sudden, the cytoplasm fills up with lipid droplets. And then if you use drugs that damage oxidative phosphorylation, the cytoplasm fills up with lipid droplets. You need a good respiration to burn lipids. And if your respiration is defective, you're going to store lipid drops in the cytoplasm as a protective mechanism, not as a fuel, not there for fuel. So clearly, and all of those lipid drops are there because the respiratory system of the cancer cell is defective. It can't use the lipid drops because the mitochondria are defective. Nothing could be more clear than this. So how are the cancer cells surviving? They're storing the lipids because they can't use them. And if they do get into the mitochondria, they cause reactive oxygen species, which will kill the cell. So the cell stores them only because it's a protective mechanism, not because they use them for energy. So, and every one of those cells I looked at every single of those major cancers, and then I looked at the number, structure, and function of the mitochondria. Not me. This has been done by hundreds of scientists over the decades. All you have to do is get their papers and look at it. And every one of the cancers that stores lipid drops has abnormalities in the number, structure, and function of the mitochondria. How clear is this? So then how is the cell living? Oh, they're sucking down massive amounts of glucose and glutamine, the two fermentable fuels that are keeping the cells growing. Oh, wow. Do you think if I pull the plug on the glucose and glutamine and transition the body over to fatty acids and ketones, the cancer cells might die? Yes, they die.
Yeah. And so essentially, for cancer prevention, obviously it's mitochondrial health and we can talk about what that is. And then for cancer treatment, for all of the major cancers, including blood cancer, and that's super interesting because I often hear people say, not a ketogenic diet for blood cancer. That's, it's not a thing. But essentially from your work and the work of other scientists who actually, if you look at the research, being in nutritional ketosis, however that looks, is going to help with the cancer management and treatment because it's killing cancer cells.
Right, exactly right. So the cancer cells are not flexible. You have to realize they're locked into a fermentation metabolism. They can't get out of it, and their nucleus, they do have all kinds of mutations. We're not saying there's no cancer cells, but there are some cancers that have no mutations. You got to realize that. And then we found out recently, and they're publishing all these papers showing that these so-called cancer driver genes, the ones that are really the ones, okay, they're loaded in all of our normal tissues that never become cancer. So I've always asked the guys from who think cancer is a genetic disease, how do you explain cancers that have no mutations and then all these driver mutations in normal cells that never become cancer? And they stare at you like, they don't even know what to say. It's like, and you guys are supposed to be smart, right? They don't know what to say because, we haven't figured that out yet. Well, you know why? It's not a genetic disease. Get out of the way, man. You're standing in the way of progress. So, and yet these guys hold prominent positions at the top medical schools, in the hospitals, and in the pharmaceutical industry. So they're standing in the way. You got to get these guys out of the way. So you're right. Protecting your mitochondria. Don't forget, our ancestors during the Paleolithic period were always in a state of nutritional ketosis. They did not have delicatessens on every corner back in the Paleolithic period. Highly processed carbohydrate foods did not exist for hundreds of thousands of years in our existence. So we were always interested in the sweet. Oh, it tastes so good. Honey, you get your face stung. I always was wondering, our technology, our intellect is so wonderful at times and so interfering at other times. Who was the first guy a member of our species who learned how to use smoke to make the bees not sting your face?
Yeah. It's amazing, right? It's amazing how these things come.
Or the dumbass bear has to have his tongue and his eyelids stung. He doesn't have enough functional brain cells to know that you need smoke to make the bees not sting you.
So true.
Right?
Yes.
I mean, so all of a sudden we got sweet honey. We don't have to get ourselves stung to get it. But then we started developing, sweet corn. And I knew the guy who developed John Lona was on my Ph.D. committee. He developed sugary 4, the gene that made corn really sweet.
Oh,
so
amazing.
then you can make alcohol from it now, and you can make all kinds of stuff from sweet corn. But that was our technology, learning how to manipulate our environment better than other species. But the downside of that is we have to pay the price of our incredible advances in technology, and that is cancer, cardiovascular disease, all these other chronic diseases, and dementia. They're all related to one form or another of mitochondrial dysfunction. So and the mitochondria in our ancestral period these guys were always in a state of nutritional ketosis because they were very active. The foods they ate, don't forget, our ancestors would eat anything that would walk, swim, crawl, or fly on this planet. There was no vegans. There was no vegetarians. You would eat anything that came. Otherwise, you and I wouldn't be having this conversation today.
Yeah, it amazes me that red meat gets thrown under the bus for things like cancer and heart disease. And I'm like, how can you even think about red meat being in that context when look around you at what everyone is eating? Like, if anything, we're all eating less of, the stuff that has been around for thousands of years. It's crazy to me.
I mean, can you imagine one of our Paleolithic ancestors saying that he hasn't eaten anything for 3 or 4 days, maybe a week, and his buddies are chopping up a deer and just, cooking it and eating. He says, "No, I'm sorry. I can't eat that. It might give me cancer."
Yeah, it's crazy.
It's absurd. It's absurd on every level. And what we found is that most of those folks died from infections and injuries and things like this. And the corollary here is domestic dogs. Cancer is the number one killer of domestic dogs. They're eating the same crap food that we're eating. They're all highly processed carbohydrates. The wolf, every dog that we have comes from the wolf. The wolf doesn't eat kibbles and bits or sugar frosted flakes or vegetables. And the number one death of wolves is not cancer, it's injuries. One of my students looked into this. What are wolves? Because, veterinarians, they spend their biggest activity, veterinarians, is to euthanize and sterilize animals, right? What the hell are you euthanize? Well, he's got terminal cancer, so we have to euthanize him. Or you're going to sterilize him. This is what a lot of vets do. But the question is, so many of these poor dogs and cats and these animals, the domestic animals, are dying from cancer because the crap food they're eating, and they're not getting the exercise that the wolves and their ancestors would get. I mean, it's so clear. It's a diet and lifestyle issue for us and for our domestic animals. So, and how do you prevent that? Well, we have to restrict carbohydrates. We just have to know. Exercise. I just said, have friends, get a good sleep, exercise a significant amount, reduce your stress, and maybe saying this stuff might be easy for some people, but not for all people who are living, paycheck to paycheck, sitting in traffic. Get the cheap meals are there. A big drive into McDonald's. I mean, we have all these fast food places here in the United States. You don't even have to unask the car to go inside. They hand you the food right through the window. I mean, you talk about a lack of exercise. I mean, give me a break. And we got a worldwide obesity epidemic. It's overtaking starvation is the number one. Can you believe this?
And Professor, what about for the people who say, hey, like you actually mentioned it earlier on, like there are people who would be what others would term the picture of health, yet still develop cancer. Like, what is happening there?
Well, we have to look carefully at their diet and lifestyle, and it's not just one thing.
Yeah.
It could be a lot of stress.
Yeah.
I've seen so many people telling me about they exercise, but then all of a sudden they lose their job, marriage falls apart, death in the family. All these things impact tremendously. And then there are other people that look like the spitting image of health. But who knows what they're taking, supplements to make their muscles look good. I don't know. But let's not focus on the few guys that look like the picture of health. They might be a rare one, but the majority of people getting cancer are morbidly obese. They have a lot of, they're smokers, they're drinkers, they don't exercise, they got all kinds of health issues in their body, and that represents the majority more. And then the young people, I'm seeing more and more people in their late 20s and the mid 30s coming down with colon and breast cancer and all these kinds of cancers, and again, it's diet and lifestyle and exposure to toxins in the environment as probably responsible for 80% of what we're seeing.
Professor, have you seen in your work over the last couple of years I don't know if it is rhetoric, but the talk around the relationship between COVID, the vaccine, and increased cancer prevalence? Is that something that you've looked into?
Well, I hear a lot about it.
Yeah.
It's like a lot of hearsay. I don't see any big epidemiological studies. I mean, how are we going to know whether that guy how many people did I got three injections of this COVID, these vaccines, eventually, I mean, when you consider how much cancer is already in the society, what do you think the probability is of someone who got vaccinated against cancer and blames it on the vaccine? Not to say, no, I'm not saying that the vaccine may have caused cancer in some people. They call them turbo cancers. I don't care if it's it's still fermenting. What the hell, we can't live without glucose and gluten. Who cares where you got it from? You could say that about anybody who has cancer. How did I get this? We don't care. Once you have it, how are you going to manage it? So what are the characteristics of the cancer that you have? Well, it's growing out of control. It can't live without glucose and glutamine, and it can't switch to ketone bodies or fatty acids. Okay, now we have a clear strategy on how to manage your cancer. What's the problem with this?
Yeah, Professor, so with the nutritional ketosis for cancer management, obviously the glucose is a really easy one for people to, it appears easier for people to be able to sort of pinpoint in their diet. Glutamine is like in almost every protein food that you can eat, isn't it?
Yeah, I think again we have to know prevention versus treatment. Exercise lowers fasting and exercise lower blood glutamine. Okay. So,
yes.
And then we built the glucose ketone index calculator to help cancer patients know when they're in a state of nutritional ketosis. And I agree with you. So, fasting and these kinds of things can certainly lower the glucose. Exercise can lower the glutamine. But glutamine, as you said, our bodies are so essential. Glutamine is such an essential nutrient for our body. It's drives our immune system. It maintains the health of our microbiome and our gut. Plays a role in the urea cycle. I mean, it's considered a non-essential amino acid because it can be made from glucose. So let's lower the glucose and then let's target the glutamine. That's what the concept of my press pulse therapeutic strategy was, because as you're right, it's much easier to lower the blood sugar than it is to target and the glutamine. So that's why we have to pulse the glutamine with drugs. And this is the tip of our spear right now. How do we improve dosage timing and scheduling for optimizing the selective targeting of glutamine while the body is held back on the glucose. So it's easy to press glucose and keep the noose around the glucose neck. But the glutamine is an essential. So we use drugs. I wish they were available, because why the best drugs on the planet for managing cancer are not widely used is one of the great phenomena that I have to deal with. Because we can do it with certain parasite medications, but the drug that we found was 6-deoxynorlucine, which is it was made from it's an antibiotic kind of thing. Oh, they said it was too toxic. Well, yeah, man, you didn't use it the right way. Anything can be toxic if you don't know how to use it. We figured a way out not to get it to reduce its toxicity. But you pulse that, and what it does is it shuts down the glutaminolysis pathway, where you can get energy from mitochondrial fermentation. This is another thing I don't want to go too deeply into, but this was the mystery that Warburg never could figure out, or any other person in the cancer field that we have now discovered, is that the mitochondria can produce energy through fermentation, not using oxygen. So it makes everybody bewildered. Like, are you sure this is the organelle that's supposed to generate energy through oxygen? And you guys found out that it can also ferment? What does it ferment? It ferments glutamine. Okay. And it dumps out succinic acid into the microenvironment, just like lactic acid, which acidifies the microenvironment. So what we do in the pulsing, we use small doses of glutamine targeting drugs while the glutamine targeting drug while the glucose is held low. Now that will slaughter these tumor cells, but you can't keep it on. You have to pull it off.
Because they're toxic.
Yeah, well, it prevents your immune system from working. Okay. Now, interestingly enough, the drug does not kill our immune cells. It just paralyzes them. But it actually kills the tumor cell, but it only paralyzes the immune system. So what happens then is that you got to pull the drug off, and the immune cells all of a sudden get healthy again, and they go into the microenvironment and dissolve and clean up the dead cancer cell bodies, the bodies of dead cancer cells. So you got to let our immune system work to clean up the mess. Okay, we're pulling off the glue, we're taking that off. So a few cancer cells do in fact come back, but then we wait, and then we come in again with the pulsing. Yeah. So you press the glucose, pulse the glutamine, press, pulse, and I discovered that. I just read all kinds of different things, and paleobiologists said that was the mechanism by which caused massive extinctions on the planet in the past. So we always had stressful events like volcanoes and earthquakes and this kind of thing, but never killed them all off, because you only kill off the weak ones. But to kill off everyone, you need the combination of a chronic stress together with a massive pulse, like a meteor strike or something, or massive numbers of volcanoes going off, which was responsible for mass extinctions of organisms on our planet. I simply took that concept and I said, let's make a cancer therapy out of it. And it developed into the press pulse therapeutic strategy based on the mitochondrial metabolic theory of cancer. And it's going to be the future. There's no question about it, because it's logical and it's based on hard science.
Yeah. So with the glucose ketone index, what is the desired number there? And if someone is intermittent fasting and it's not giving them a sort of excess energy, I guess, or calories, exogenous ketones or MCT, are these strategies people can use to get into?
Yeah, I think they work certainly for a short period of time. We're not opposed to excess ketone bodies, exogenous ketones or something like that, as long as it doesn't throw up the glucose. So people, and now, everything now is like Keto Mojo or some of these other meters where you prick your finger and you get a drop of blood, like a person with diabetes, and you read the glucose, and the meter reads the glucose, and then you can take the same drop of blood or another drop and put a ketone strip on it, and it will give you the ketone. And then Dorian Greenough, who developed the Keto Mojo from our calculation, I could never patent the calculation. They said, "Oh, you can't patent calculations." So Dorian now put the formula inside the Mojo meter, so you don't even have to do arithmetic. You just push the button, and the meter gives you the ratio.
Oh, amazing!
So it tells you, yeah. So it tells you. So this allows us to be more. So people say, "Oh, my blood sugar is high," but what about your ketones? Oh, they're high too. We'll do the division, and now it doesn't look so bad.
Okay.
So the issue here is that is a guide. And what we say for cancer management is cancer patients, they're so far out of metabolic homeostasis in so many ways, not only from a poor diet and lifestyle or from the stress of having the cancer or all these other things, that their GKI values are always very high. So you really got to get them low, and stress management will do that. And once you're into that low GKI zone, we measure all the blood work. We got to move the patient back into a state of metabolic homeostasis, and that's when you come in with the glutamine targeting drugs. Now they're going to be much more effective, and so will certain chemo and radiation. All these things become super powerful with minimal toxicity as long as you're into the low GKI. So, and that can happen from a variety of different ways. And it takes the anxiety out of a person. For the first time, the cancer patient is now participating in a significant way in their health. So they will work with the knowledgeable physician as a team. And the physician will say, today, at this time of the day, you're going to have hyperbaric oxygen and the glutamine targeting drugs and the things that will just blast these tumor cells out of existence. And you'll do it a graded way. So, and the person gets healthier and healthier. If you look at the diagram that I put together, I think it was a Leonardo da Vinci diagram of the human. You can see how we move the cancer patient from a state of unhealth to a state of semi-management to a green state of potential resolution or long-term management. So the patient gets healthier and healthier as you slowly degrade the tumor. This is very, very different than what we're currently experiencing. When you see these people treated by standards of care, I mean, a lot of them look like they just came out of a concentration camp. They're bald, they're gaunt, they're vomiting, they got headaches, they got their lips are all swollen. I mean, this is nuts. You don't have to do that to people. You just have to know the biology and the biochemistry of the disorder you're treating. And we're going to save so many lives. I'm telling you, but how long is it going to take before we remove the dogmatic ideology and the confirmation bias? That's what's standing in the way of all this.
Yeah.
Dogmatic ideology and confirmation bias.
And so with the nutritional ketosis, protein intake has to be low. And then I guess some people...
No. Okay. We did a study. Anybody, you can be a vegan, a vegetarian, a pescatarian, a Mediterranean, or a carnivore. Again, you're eating small amounts. You look at the GKI, and it seems like the people who are carnivores, I don't say one way or the other. They seem to drop into these GKIs faster than vegans or vegetarians. Okay, so if a guy, and we have to make these diets culturally appropriate. Okay, the guy from China might not be eating the same guy as Ireland or whatever, So you have to eat what you. And then I said, "Oh, can I eat this? Can I eat?" I have no clue. Why don't you eat it and see what it does to your GKI? If the GKI skyrockets, don't eat that. So, and then they say, "Oh, but I'm trying to eat anything." I said, "Don't eat anything. Just drink water for a while and see what happens." And all of a sudden, oh my God, my GKI is down. And they said, "Well, now you know what to do." And they say, how long do I have to live like this? Well, I said, you wouldn't have to live like that if we could use the power of the glutamine targeting drugs that we could put on. When you're in that wonderful state, man, your tumor cells are hanging on for their bare existence. You come in with a slight shot of these glutamine targeting drugs, and you're going to mass kill these tumor cells without toxicity. So again, but the problem is that what I'm saying to you is just incomprehensible to the entire cancer industry.
No, completely.
It's just like I might as well be speaking in a language coming from a different planet.
Yeah.
You know?
Professor, how available are the glutamine targeting drugs?
Well, they're not. The key one is not available. I mean, I get you if you have a research lab, you can certainly get it. But why it should be available, and every oncologist should know how to wield the power of these glutamine targeting drugs. In the absence of that drug, Don, somebody can make that and make a lot of money. That's the whole thing. The whole thing. What I'm talking about, it's not a big moneymaker yet. And I think that's probably another major obstacle, because you can't undermine these massively profitable institutions without having something to substitute for that. So, but we use embendazole, fenbendazole, these parasite medications. We have a paper that's published for high-grade glioma in children. That's another tragedy. Oh, don't get me started. These poor little kids with the glioblastomas, the brain cancer. So sad. It's just tragic beyond comprehension. You see these little kids sacrificed by poison and irradiate them, and it's just terrible. But anyway, we have a model for pediatric cancer that we've developed here at Boston College that manifests all the characteristics you see in little kids. So we used our drug diet treatment on it. We used embendazole, and then we looked at embendazole actually will facilitate targeting of the glucose and glutamine pathways, the glycolysis. But it's not as powerful as the other drug, but it's not bad. So once you're in ketosis, you can use these parasite medications, and they'll work together with the nutritional ketosis. So again, and stress management and the other things that go into the package. It's a treatment package, and you're using diet, lifestyle, drugs, and a variety of procedures to stay alive. And the patient and the families of the patients are all working together with the oncologist as a team effort.
Yeah, and exercise is obviously one of the super important parts of the puzzle.
Yes, absolutely. Exercise is you keep your body, because it makes the mitochondria healthy, and you use more oxygen. So the normal mitochondria get healthier and healthier, and the weaker tumors they start up and dying from this. So it's a whole body reconfiguration, and the patient plays a major role in the outcome. The eventual outcome. They're not going to be just sitting there like some pawn or some bystander. Well, some person with minimal knowledge of the biology of the disease that he's treating. It treats you with all this medieval stuff, and the patients pay a huge price for this. I mean, even the survivors, the so-called cancer survivors, they say, "Oh, I'm a cancer survivor, but now I've got hormonal imbalances, neuropsychiatric problem, gut problems. I got all kinds of problems." Well, if you just took a whole handful of young people on the planet and just gave them radiation and poisonous chemo, I mean, you're going to disrupt their health. They're not going to live on the planet as long as someone who was not exposed to that stuff. So again, we have to have a complete reevaluation of how we're treating cancer patients, but we have to do it in a way not to disrupt the revenue-generating sources that are out there.
That's the roadblock in all of the sort of chronic disease space, I think, when you think about diet and the rest of it.
Well, don't forget, you have people that, when I tell people all this stuff, they don't want to change their diet and lifestyle. So can you do it? I just want to look at the Ozempic and all this obesity stuff. Rather than exercise and eat correctly like our paleo, they want to take a shot. They want to shoot themselves, because that's what we do. We want convenience, ease. No one wants the inconvenience of doing. Not no one. I don't want to say that.
No, I know.
Of course
Yeah.
But why we have so many people that's our nature. That's what put us in this problem in the first place. So we have to know our human nature. We have to know who we are. We're greed. Greed is a driver of how we behave. Convenience is a driver of how we behave. Taste, enjoyment, a driver. So and you come along and say, I can't. Well, I'm not saying don't eat a pizza. Or a big jelly-filled donut, you can eat that stuff. You just have to know that if you eat one every day, 3 times a day, you might be putting yourself at risk for something.
Yeah. And is there utility, though, Professor, do you think, in those drugs at helping reduce the risk for developing cancer? Do we know anything about that?
Well, we don't know that yet. Only because sometimes it can take decades before you get cancer from a provocative, one of the provocative things, right? So we don't know. I mean, if person is, they like to look, they love to look good, they were before always like fat. Now oh my God, you look statuesque, this is unbelievable. You can wear this beautiful dress, but do that for 10 years and see what happens. I don't know what the outcome, and I don't think anybody does, what the long-term consequences of disturbing hormonal balances in your body. Your body has evolved over hundreds of thousands of years to operate in a particular environment. And when you begin to change that environment, God knows what's going to happen to the homeostatic systems that we have within our body. Is the risk, does the benefit outweigh the risks? And sometimes we don't know. So we just have to let those people take those drugs to lose weight as much as they can, as fast as they can, for as long as they can. So we can know in 10 years whether or not it was harmful.
Yeah.
They'll be the ones to tell us.
Yeah, for sure. And Professor, is there utility in being in nutritional ketosis from a prevention perspective for our mitochondria? Or do you feel okay?
Yeah, absolutely. I mean, I don't want to say you can't, it's impossible. It's extremely difficult to get cancer in cells that have healthy mitochondria. So, and that's why burning ketones, my late great friend, Richard Veach, head of the metabolic branch of the NIH, Hans Krebs, his last student of the Krebs cycle. Yeah, he would talk to me for hours. I learned so much from my discussions with Richard Veach and with George Cahill. Cahill ran the Joslin Diabetes Center here in Boston for a long time, and they did a lot of this basic research on patients back in the 1950s and 60s and 70s. So they were able to look at the role of ketone bodies, and they called it a super fuel. Because when cells burn ketone bodies, the mitochondria get super healthy. They reduce the amount of reactive oxygen species and the entropy, which is disorder, in the mitochondria. So clearly, when a person is in nutritional ketosis, and we define that as GKI of 2.0 or below, and that, oh boy, when it can't, now, many cancer, it's easy for healthy people like yourself and young people. They can get into these zones. For older folks and sick folks, it's a little bit harder because they get a lot of stress. And sometimes the treatments, the drugs they might be taking along prevent them from getting into nutritional ketosis. So this is another thing. So you have to know precisely how you move your body and mind through this obstacle course to get into these nutritional zones. And then you work from there into an overall improvement in overall health. And I tell you, it's unbelievable. I'm talking specifically about shrinking tumor cells, but we've seen guys, their anxiety goes away, hypertension goes away, type 2 diabetes goes away. A lot of these things get managed at the same time the cancer is being degraded. So, another thing too, I want people to know that I am not preaching here about a cure for cancer. Okay, I have no clue whether cancer will cure. Metabolic therapy, ketogenic metabolic therapy can lead to cure. I consider success as being alive 2, 3, 4, 5 times longer than what was predicted based on your predicament. Okay. So if you're saying, well, I had 6 months, the doctor said I had 6 months to live, and you're out 6 years because you did metabolic therapy, I consider that a success, even if you were to die from something, a cancer at 7 years or whatever. So, yeah. So, I mean, we don't say there's a cure. There's a pathway to longer term management. Let's put it that way. I can say the only thing that we did get a cure from was a dog that had mast cell tumor on his face, and I published that paper in Frontiers, and I think it was Frontiers in Nutrition. People can go and read it. That dog had a big tumor, and the layperson, the lay owner of the dog, just listened to my YouTube videos over and over again, and gave the dog raw chicken with the bone still in it, chopped up into small pieces, some sort of fish oil, pollock fish oil, and some raw egg. Cut the calories. The dog lost about 10% of its body weight, and within a few months, this big tumor disappeared, and the dog died of old age. A pit bull lived to be 15 and a half years of age, died from cardiovascular disease, not from cancer. So that, and it was completely gone. It was like dissolved away. Now, we are seeing people like that, but I have no idea if the cancer is cured or gone or not. It might come back. Pablo Kelly, our long-term brain cancer survivor, he's 10 years now. This next month, July, he'll be 10-year survivor of glioblastoma. It never went away. They said to Pablo, you have an inoperable brain tumor, and if you don't take standard of care radiation and chemo, you're going to be dead in 9 months. And it's written up in the British popular press. And he said, no, I don't want radiation. I don't want anything. I'm just going to do metabolic therapy. Well, they said you're going to be dead. And then in 2.5 years later, his so-called inoperable tumor became operable, and he had it debulked. And then he thought he was out of the woods. No, it came back again. He had it debulked a second time, and finally a third time. But Pablo is out 10 years. He's had 3 operations on what was originally described as an inoperable tumor. But is he cured? No, he's not cured. But since he's alive, he's got married, he has 2 children in the 10-year period from the time he was diagnosed. So, I mean, do we consider that success or failure?
Yeah.
We didn't cure his tumor. But he's
still living.
He's still alive.
Yeah.
Right?
And not just alive, he's, living, essentially.
Oh, yeah. And he has a podcast. He'll tell you what he's doing and how he's feeling and all this kind of stuff.
We've got a doctor here in New Zealand, Dr. Matthew Phillips, who uses...
Yeah, I know him. In fact, he's working with us on... Yeah, Matt is a great guy.
Yeah.
He's another guy you should interview because he's a smart guy, knows what's going on. He's doing the best he can. He's had tremendous success in managing cancer using ketogenic metabolic therapy. So eventually you get a few people that actually understand what's going on, and they're going to be the prime movers in this whole thing.
100%. And, for people, of course, we're going to link your research papers in the show notes, but on a lot of your papers, there are several tens of people that are also working with you. So I know it's that you've got a real team that sort of work with you. And one of them, of course, is Dom D'Agostino, who I've interviewed previously. And he's on the internet a lot. Sort of he's very open and transparent about his lifestyle, which I find very motivational, actually.
Right. Well, Dom is like a modern day Paleolithic guy.
Yes.
So you want to know what it's like to live in Paleolithic? Watch what Dom does.
100%.
Okay?
Yeah.
Yeah, Dom is that kind.
Yeah. Now, I want to be mindful of your time. I am mindful, but I want to be respectful of your time. 2 hopefully quite quick questions for you, please, Professor. 1, urolithin A. The
what?
urolithin A, which is like a postbiotic supplement that helps in the mitophagy process.
Well, I for some reason I'm not connecting with what you said.
Yeah, urolithin A.
Oh, urolithin A.
Yes.
I have no clue about it.
Okay, no, that's cool. We'll leave that there.
I only can speak knowledgeably about things that I have worked with and tested in my lab.
Understand, yeah.
So other than that, I have to go with maybe what others say or something.
Nice one. Chat to Dom about it, because he just did a podcast.
Yeah. Oh, well, Dom does try a lot of stuff.
Yes.
I have to be honest with you. But, for us to do a trial on preclinical studies to determine whether or not there's a real statistically significant therapeutic benefit costs about $100,000. So we are indebted to philanthropy and private foundations that support my work, who say, I want you to test this for us. Sometimes I test their drug or their procedure, and it turns out not to be what they were expecting. And then they say, are you sure you did the experiments the correct way? Do you know what you're doing? And I said, we do. Let me show you what we do. We take a group of control and treated animals, a bunch, maybe 7 or 8 in a group, and we get the result. Okay. Then we do it all over again with another group, right? And we get the result. And then we do it all over again with another group of animals. We don't make our decision based on one study. We do it over and over again, which is expensive, time-consuming, labor-intensive. But then we're pretty well sure about. It was like our study on the fluoride in the water. They wanted us to think that fluoride caused cancer. We did the study over and over and over again. And we didn't find any evidence that fluoride could enhance metastatic cancer or anything. And, wait, I'm unhappy. So it must cause something. What number do you want me to change, man? I don't know what to say.
Okay. So, and very, very quickly, artificial sweeteners, are they like the body of research? Like, obviously, you don't want to, dose yourself up beyond some ridiculous amount, but what do you think?
I don't know. They certainly help things out. Like if you're drinking bulletproof coffee, which is a really good way to bring sugar down and ketones up. Sometimes it tastes a little bit better if you throw in some stevia or something like that.
Yeah.
But I don't want to. I don't know.
Yeah.
I never tested bulletproof coffee with and without stevia. You
got to run that one, surely.
You know what I'm saying, right?
I hear what you're saying. No, I like it.
I prefer the taste with stevia. It tastes just like a latte.
Yeah, it's delicious.
But if you go to Starbucks and you get those, they're loaded with sugar, man. I mean, I don't know how people can live when you eat one of those things, or drink whatever. But bulletproof coffee is actually not bad.
Yeah.
I mean, it's a good way. One cup can like your whole day. You don't have to eat anything else.
And so clearly you live in nutritional ketosis. I am just assuming here.
No, I don't live in nutritional ketosis.
Don't you?
No. I mean, I live in it. But I don't. I try not to abuse myself with the great American Western diet and lifestyle.
Yes.
But I certainly know what I would need to do. Dominic lives like a Paleolithic guy. Anything that walks through his backyard, he shoots and he kills it, eats it. I mean, he eats squirrels and stuff. I mean, I'm not into that.
Yeah, fair call. Fair call. I totally appreciate that.
The technique he uses to cook their liver and stuff. I said, listen, Dom, I'm not there yet.
Yeah.
So, but any event, he shoots the pig in his back. Some pig threatened his wife on the horse. He went out and shot the pig and roasted the damn thing.
Oh, delicious.
You can talk to him. He's great. He shoots alligators and eats them.
Yeah.
I mean... He's no different than an Aboriginal guy, and he's always in nutritional ketosis. And look at him. He looks like the
some sort
Rock,
of gladiator. I know. And I'm so sorry, but I do really want to just clarify. So melanoma, word on the street was do not try a ketogenic diet for melanoma. Is that incorrect?
Why?
Yeah, this is what I'm asking you. Yeah.
Yeah, because they say melanoma has the BRAF or the V600. We found out, my colleague Jocelyn Tan at the Pittsburgh VA, the melanoma folks that had that mutation did best on metabolic therapy.
Okay.
So, it's completely erroneous.
Yep.
When we looked at melanoma, they have lipid droplets in the cytoplasm and dysfunctional mitochondria, meaning they're dependent on glucose and glutamine. As a matter of fact, they're more dependent on glutamine. They're very glutamine-sensitive tumor cells. So you got to shut down the glucose and glutamine. I haven't found any. As a matter of fact, every year in my cancer class, I said, will somebody bring me a tumor that you can show me growing without glucose and glutamine on fatty acids or something? I'll give you an immediate A. You don't even need to take the class for any longer. And I've been doing that for 10 years. Nobody's been able to find this. And then when I go to big meetings, I tell the scientists there, they thinking they know what they're talking about. I said, go ahead, you show me the cell. Oh, I'll give you the paper. Okay, well, sure. I never find the paper. Guys never show me the paper. And when they show me the paper, there's always some glucose or glutamine in the media. I said, you didn't get rid of the glucose and glutamine. Oh, I missed that point. Well, I'm telling you shouldn't miss that point.
Yeah, that's a super important point. And then my final question, Professor, is I know that, so obviously there's the standard of care, and we've talked a lot about that, but then you also have clinics that are based like in Mexico or Thailand where they do not do the standard of care, but they do all of these other very expensive treatments and they people go there and spend tens of thousands of dollars with a lot of hope that this is going to help either with the standard of care or instead of but it's different from obviously the published research that that we're talking about. So thoughts?
Yeah, well, as I said, I published this. We publish our case reports, our findings. I don't have any clue what goes on down there in Mexico. All I know is I have Mexicans from Mexico emailing me and wanting to come across the border to get metabolic therapy. So I don't know what's going on with that.
Yeah.
You know, if they're so good in Mexico, why don't they go there? It's less, you know. And I've spoken to some of those folks. They're not doing what we say to do.
I know.
Oh, I want to add this supplement. I want to do this. No, you got to. We're writing a big treatment protocol as we speak with more than 30 scientists and physicians. Matthew Phillips is one of the authors on this.
Nice.
Co-authors on this, and this will be the guide for setting up clinics all over the world. Because it's a how-to manual. It's a protocol, comprehensive protocol. To do this in this way, if something is different, switch to that. That each person must be viewed as their own control. So what might be good for you may not be good for me or this other guy. We have to look at each person as an entity, a physiological, biochemical entity, and we see their parameters and how they stack up with respect to metabolic homeostasis. And then we move that person under these conditions, which may not be the same as someone else with a different cancer, different age group, different body weight, all these different kinds of things. So that's what makes our metabolic therapy not quite perfect or even similar to what we're doing in these big pharmaceutical companies where you do double-blind crossover, just treat a bunch of people with the same dosage and see how they turn out. No. Each person is their own control. So that you have to have a knowledgeable cadre of nutritionists, dietitians, oncologists, and scientists that know how we're going to move this person from this state of health to an improved state of health while degrading not only degrading the tumor, but enhancing their overall state of health, so they emerge in a new state of homeostasis. So, how do you incorporate this into a big clinical trial? I don't know. I can say only that we need to change the way we're doing clinical trials. Okay, and then the people will emerge, and like Maggie and Brad Jones are cataloging all these stage 4 cancer patients on their Cancer Revolution documentary. All these people, they all did something a little different from the other guy, but they all did metabolic therapy in one way or another, and they're all really showing tremendous success. And the system, so that's all a fluke. How many damn flukes do you want?
No, I know. Yeah.
Before you realize that this is working if it's done the correct way. But again, if you go to Mexico and you have a bunch of guys that have no clue what they're doing, their results aren't going to be any better than going to MD Anderson or Dana-Farber or Sloan Kettering. Or the major hospitals in New Zealand or Australia or wherever you want to call them. You know, if you use standard of care by itself, yes, you're going to get survivors, but you're going to get a lot of dead people too, or people that are seriously injured from the treatments you're giving them. We don't want that. We want to make sure these folks emerge with a healthier attitude in life, healthier physiology, if they want it. Some of them say, I just want to take the pill and go from there. Okay, well, that's your choice.
Yeah, no, completely.
So we don't force anybody to do anything they don't want to do.
No, and as I understand it, and as we've been talking about, this is in addition to, in a lot of instances, the standard of care, but the standard of care can be dosed correctly. It can be much more potent on the cancer cell, and then your healthy cells are protected.
Well, you have to have oncologists that know this and are flexible. And so many of them are not. And I feel one of the great problems that I have is you hear me speaking on these podcasts and telling all these millions of people. And then these guys go, oh my God, we got the way to manage cancer. And then they go to their oncologist and get slapped down. They never heard that glucose drives dysregulated cell growth. Can you believe this? They never heard of Otto Warburg. It's my way or the highway. And that's what they say to the patient. Oh, you can leave now. I don't even want you as a patient. And the poor patient goes out onto the street saying, what the hell just happened? I was all excited about this guy, hoping to think he hears this, and then he gets slapped down. And by the lack of knowledge on the part of the providers, which is a tragedy in and of itself. So again, we're not training the physicians to know how to treat cancer as a metabolic disease.
And Professor, is there in the future, will there potentially be some sort of like CME or with the press pulse. That's to go in and teach the oncologists and the people who need to know.
Yeah, that's right. And that's hard to raise money for because my colleague Josephine Barbarino from Germany and Switzerland, she has already a place in Switzerland to set up to train physicians, nutritionists, dietitians in the correct way to treat patients with metabolic therapy. But we can't find anybody. People who like to invest in things always want a payoff. Like if I invest this much money in this thing, I'm going to reap tremendous benefits. Well, the only benefit you're going to reap is keeping people a hell of a lot healthier. Oh, but where's the bottom line? Where am I going to make a buck on this supporting metabolic therapy so you guys can set up the clinics? I think when the clinics are set up, you might be able to make money on high throughput treatment of patients by a knowledgeable cadre. I'm not saying we shouldn't make money on metabolic therapy. The idea, where is the brilliant entrepreneur who is going to know how to convert the whole system over to a very profitable way? I don't think people will mind investing money or paying prices if they know that what they're giving is going to work.
Yeah, I completely agree. It's what a real shame that Bill Gates isn't interested in this, and he's much more interested in getting rid of every single cow on the planet. Whatever.
Well, cow and malaria. I mean, malaria is also an important. They invest a lot of money in malaria. It's also a very important disorder.
Yeah.
But yeah, I think cancer is the big dog here on our planet, and it strikes the fear of God and into your soul. And your whole body changes just by the diagnosis itself. And that shouldn't be. It should be just looked at as, damn, I got this tumor, but now I have to spend 6 or 8 months getting myself healthy to get rid of it.
Yeah. And I will say, Professor, that how you just described the sort of diagnosis of cancer is exactly, or the fear of it is exactly what I live with. But talking to you and diving and looking at your research and learning more from the likes of you and Dom and your colleagues. I'm talking to Isabella Cooper, actually, in a month or so. It really does make me feel more confident, if you like, that there is a path out or a path forward. Whereas,
the path is that you are in charge of your destiny.
Yeah.
And your adaptation to recognizing the information and applying it to your particular situation gives you the power. Like I said, if I ever had cancer, I would, even though I write all the books and the strategies, I would still talk to Alicia Halakis and Miriam Kalamian and some of the people that I've worked with. And I would do, because they're in the trenches dealing with these kinds of people and all the time. And they would have great assistance. And I would work with them. And if I did not survive, at least I would know that I survived doing everything I could and not turning my soul over to an establishment that really has no clear understanding of what they're doing in relationship to the biology and biochemistry of the disease they're treating. So if I go out, I want to know it's on my terms, not on someone else's terms.
100%. Professor, thank you so much for your time this morning. I've really appreciated it. Really enjoyed this conversation. Obviously, I'm going to put links to your ResearchGate and your publications and laboratory. You're not active on a lot of social media, are you? I mean, you're on a ton of podcasts, which is fantastic.
Yeah, no, I have the Twitter account,
X. Yes,
and I have some of my students are now doing Instagrams and stuff. I don't know what to do. The idea here is those people that have more savvy with those kinds of things. But I do have an X account, Twitter account, and I do highlight some of our publications on there.
Yeah, amazing.
For that, and as again, Travis Christofferson's Foundation for Cancer Metabolic Therapies. It's interesting. If you go into my publications. There's an acknowledgement section there, and you can get an idea of who's supporting our work. A lot of it's just names of people. Like, who are these guys?
Yeah.
Well, they're the philanthropy guys.
Okay, no, that's good. And I did actually listen to a podcast with Travis a few years ago, actually. He wrote a book, didn't he? I think. But it's
Oh,
amazing stuff.
His book is doing. My book is selling like hotcakes now. I can't figure it out. It's 12 years old, and I sold more copies in 1 month recently than I sold in the first 4 years.
Goodness.
So people are finally realizing that cancer might be something other than what people thought it was. It's a metabolic disorder. So, but Travis's foundation supports us and philanthropy. I'm always admiring people who say, I don't need to make a lot of money. I just want to know I'm part of a revolution, of a paradigm change. And the fact that I might have helped it a little bit makes me feel good intrinsically. I like those kinds of people because they're not asking me to, you got to produce this and produce that and produce that. They say to me, I know you're right. I know what you're doing. I just want to know I'm helping you out.
No, I agree. That's amazing.
They're not going to run another experiment on a drug that may or may not work.
100%. Professor, thank you so much. Enjoy the rest of your day.
Yeah, thank you very much now.
All right, team, hopefully you really enjoyed that conversation, or at least gave you something to think about and to explore further. So I cannot recommend his work highly enough. And of course, I have spoken to Dom D'Agostino on the show before, and we did have some conversation in and around cancer and ketogenic therapy too. So I'll pop a link in the show notes to that episode. Next week on the podcast, I speak to Dr. Mike Ormsby about exercise physiology and nutrition, all the good stuff. Until then, though, you can catch me over on Instagram, Threads, and Twitter at Mikki Williden, Facebook at Mikki Williden Nutrition, or head to my website, mikiwilliden.com, and sign up to the recipe portal, where you get over 900 amazing recipes that you can add to your recipe repertoire. All right, team, you have the best week. See you later.